We already know that electrons move, or some electrons move pretty freely through a metal. Those moving electrons, remember, they're charged. They don't have a lot of mass, but each one has a negative charge. So they are constantly repelling each other. They tend to maintain their distance from each other. So it's kind of like those interactions, those repulsive interactions, tend to even out the momentum of particles. It's kind of like if you had a glass of water. It's not like some some mass of water molecules in the glass are going to be moving really fast, and then another mass of particles right next to them are going to be moving really slowly. You're not going to have pockets of super hot and super cold water right next to each other. Or if you do have that temporarily, let's say you pour boiling water into a like a cool uh, cup of tea or coffee to warm it up, the those the momenta of those molecules is going to even out, right? So pretty quickly, the entire cup of tea is going to be warm because you're going the molecules are going to equalize, and you have the same sort of thing happening with electrons. So the momenta of the electrons tends to even out throughout the substance. In a polymer, you don't have those free flowing electrons. They're usually bound tightly to their atoms or molecules. And so the heat conducts differently through something like a polymer or a nonmetal than it does through a metallic substance. In a piece of metal, the nuclei of the atoms and their low energy electrons, remember the low energy electrons are those at the lower energy levels. They actually have less energy. That's why we call them energy levels. So the inner energy levels of electrons and the nuclei are in a lattice. They form a crystal structure, they form a regular structure. And then the higher energy electrons can move really easily from atom to atom. That's why we say a metal is like the nuclei in us, or a metal or metal something with metal bonds is like metal ions in a sea of electrons, not just the nuclei, but the metal ions. So it's the metal and the inner levels of electrons in a sea of the high energy electrons. They can move easily from atom to atom. So if you compare them to the motion of particles in a solid, liquid, or gas, it's kind of similar to a fluid. A fluid can be a liquid or a gas. The electrons are free to move and they can transfer a force. However, they're charged. Um, and so their most significant feature is charge, not mass. So when a liquid particle flows, its mass can carry something along with it, right? You can be caught up in the stream, in the current of a stream, or in the tides of the currents of the ocean. But with the electrons, they're charged. Uh, in fluid, they're usually neutral or closer to neutral, and so it's actually as electrons flow, that charge can produce a force that can do work and move objects and generate heat and do all the stuff that we know electricity is able to do.